let's try a more complex one. So aluminium, it has a Young's modulus of 70 gigapascals. I mean, different alloys will have different Young's moduluses, and has a working, we're going to put a working stress. This is the maximum stress we want to put on it, and this will allow a safety margin of 22 megapascals. Okay, most aluminiums handle much more than that, but we don't want to break this thing. So a 12 meter or a 12 meter aluminium bar, aluminium hanger, 20 millimeters by 40 millimeters. It's cross-sectional. What is the maximum load that's going to stay within this factor? What is the stretch? Is the change in length. So we've got two things going on here. So we write down an equation. So we draw a picture first of all. So we have this is how long? 12 meters. We don't know what the load is, so we're going to work that out. There's going to be a change in length. We don't know what that is. We're going to work that out. And what do we know? Well, we know the cross-sectional area is going to be 0.02 meters by 0.04 meters, and we know E and working stress. So let's write down equations. We know E is equal to stress over strain. We know stress is equal to force over area, and we know strain is equal to change in length over the original length. So we're basically going to ask, what do we know and what can we work out? So what do we know? I know E. What else do I know? Do I know stress? I know the maximum stress. Yeah, so that means I can work out it. Stress, well, I know the maximum working stress. Force, no. Can I work out the area? Yeah, so I can work that out. That means I can work out the force. And what about strain? Well, I can work out strain up there. I know the original length, so therefore I can actually work out everything here. Let's try this. So let's rearrange this for strain. Actually, let's start here. What's the maximum load? So force is going to equal, let's just rearrange this equation. Force is equal to stress times the area, which is equal to 22 megapascals times the area of that's going to be 0.02 meters times, because this is actually a rectangle bar. This is not actually a circle, so it's going to just be base times the height. So it's going to be 20 times 40, which is going to, so we can go 22 x 6 times 0.02 times 0.04 equals 17,600 newtons. So about 1 3/4 ton, roughly, very roughly. Okay, so we've worked out what's the maximum load. So that's the maximum load with the system. Well, let's work out this one. Strain is equal to stress over Young's modulus, which is equal to, what's the stress? We said the maximum was going to be 22 megapascals. That's the maximum safe working stress. And what's 70 gigapascals? 70 gigapascals. Okay, so we go 22 x 6, that's 22 megapascals, divided by 70 equals 0.0003143. So that's going to be the strain. And now I can put this to this equation. So I can go rearranging this, change in length is going to equal, it's going to equal the strain times the original length, which is equal to 0.0003143 times 12 meters equals 3.771 times 10 to the negative 3 meters, which is equal to 3.77 millimeters. So if I put 1 3/4 ton on that rod, it will stretch just under 4 millimeters.